Guys, this video is about populations. This is topic 5.3 of your syllabus, and this coincides with chapter 53 with the AP biology textbook. So let's begin with the definition of what a population is. A population is the total amount of individuals of one particular species within a given area. And why do we study populations? We study populations because it's a great way for us to monitor endangered species. The numbers of endangered species of elephants, lions, things that you hear statistically, it's because we're studying populations. We can study and monitor the environmental health, which is very good because we want to know how many cases of West Nile are in a local area, how many cases of AIDS we have across the world. We can monitor change in an area over time. So if the change in the area is decreasing, we may need to do something to save the population of the species so that they don't become endangered. We can use this in politics to make very political decisions. We can use population studies to estimate the demand for natural resources. Looking at these natural resources, we can specifically study the driving force behind human environmental damage from the increasing demand that is placed upon our environment. So let's look at 5.3.1. With 5.3.1, we want to outline how population size is affected by natality, immigration, mortality, and emigration. So let's look at natality. Natality is the birth rate, how many are born, and this can increase due to the amount of food that is available or if there's a minimal amount of predators around. And so we can actually have a max birth rate that will lead to an exponential growth, which we'll see later when we actually look at a graphical representation of population size. But simply put, how many people are born, what's the rate of births for that species per given amount of time, and this will increase due to the amount of food and how scarce our predators are. Next we have mortality. This can affect our population size, and mortality is death rate. So natality is birth, mortality is death, and the rate itself may increase and decrease, but we see the mortality rate, the death rate, actually increasing because of famine, diseases, and predators. These three things, you're going to actually see that death rate increase. Therefore, the population size possibly could decrease. It's going to depend on all of these factors working together. Third, we have immigration. So immigration, I, is inward movement of an individual to an area. We see this through human beings, our family members immigrating to America, or we've seen some teachers that have immigrated to other countries so they could teach in a different country. So this inward movement of individuals to an area, some species actually have annual predicted immigrations. For example, zebras and birds, they immigrate and they migrate to different areas at different times of the year. And then lastly, emigration with an E. Emigration is the outward movement of an individual to an area. So the individual's leaving one area and moving out. So my mother had immigrated to America with an I, but she emigrated with an E from the Philippines to America. And sometimes this happens when the sources are scarce because certain species, they've depleted their sources, predators have come along, or another animal has competed for those sources and now they have to emigrate and move to a different area. This is a great representation of how natality, immigration, mortality, and emigration actually affect a population. You can see that these two right here, something moving in and something being born, should have a positive effect on our population. And then over here we have in red mortality and emigration. Those two things can cause a decrease in the size of the population, but you have to consider all four of these things working together to actually determine what the population size is per a given moment in time or looking over a collection of time. So we want to ask the question, when does the population grow? And you can easily make it, look at this mathematically. When immigration and natality are greater than emigration and mortality, you're going to see an increase in the population, which you can see from that increase in the graph. And then when would a population stabilize? It's about when what's coming into the population and what's leaving the population is about equal. And notice how this line kind of fluctuates like a wave. It's because we're never going to have a precise, straight, exact line because this is going to be some sort of balance. So you could see that it's kind of balancing itself out. So we'll never say that population is going to be, the rate of population growth is ever going to really equal 0. That's almost impossible. But we will see it stabilize when immigration and natality approximately equal emigration and mortality. And then when is a population going to decline? Well, if your immigration and your natality are less than your immigration and mortality, then the population size will decrease over time. And that's this simple equation, I plus n minus the immigration plus mortality, is our population growth. And I would recommend that you draw these equations, draw this graph this picture right here. This is a great way to remember for your assessment statement how population size is affected. This would be a great thing that you could just redraw, scan it, and put it onto your IB website. And that's it.